Welcome and thank you so much for joining me. So this video is in regards to learning about isomorphic graphs. This means graphs that are equivalent. So for a network to be equivalent, we need to make sure that we have the same number of edges and vertices, and the vertices have the same degrees, and the edges connect to the same vertices. So if I look at A and B, sorry, A graph 1 and graph 2, there we have a vertex, we have a edge that connects A to C, but if and C is only connected to A. Whereas graph 2, it shows me that C is also connected to B. Because of that, they are not isomorphic graphs. Whereas if I look at graph C, A is connected to C and B, and the vertex C is only connected to A, exactly the same as graph 1. Likewise, if I think about the number of vertices I have and the number of edges are the same. I've got 3 vertices, 2 edges. If I look at degree is how many pathways I have. So C has got 1 pathway. A has got 1, 2, 3. And B has got 2. And that is the same with graph 1. B has got 2 pathways, 1, 2. A has got 1, 2, 3 edges attached, so that's 3 degrees, and C has got 1. Let's have a go at 2 more examples. Okay, if we look at question B, we've got 3 graphs again. So straight away, if I want to look at this, I'm going to look at A and C. I can see with my graph 1, I've got two edges going off the vertex A to C. Where in graph 2, I've only got 1 going to C. Let's look at my graph 3. Same with graph 3, I've only got 1 going to C. So I'm pretty sure that graph 1 is not our isomorphic graph. Let's continue and double check the others. So if looking at C, C is connected to B 2 ways. It's connected down the middle and around. Likewise, C here is connected 2 ways. And I can see I've got 1, 2, 3, 4 edges. And here I've got 1, 2, 3, 4 edges and the same amount of vertices. I'll double check my degrees. A has got 2 degrees, 2 edges attached to the vertex. C has got 1, 2, 3 edges attached, and B has got 1, 2, 3 edges attached. Likewise with A has got 2, B has got 3 edges attached, and C has got 3. So it's the exact same. So graph 2 and graph 3 are isomorphic graphs. Let's do one more example. And that is our question C. Straight away here with question C, I can see I've got 1, 2, 3 edges. So I must have 3 edges. Whereas graph 3, I can see I've got 1, 2, 3, 4 edges. So straight away, I already know it can't be graph 3. I can see each of my vertex has 2 degrees. Likewise in graph 2, it's got 2 degrees. So which means I know that graph 1 and graph 2 are isomorphic graphs.